Welcome to an application of perimeter. In high school, Frank's basketball coach made the team run 15 times around the entire court after every practice. The dimensions of a high school basketball court are 50 feet by 84 feet. This measurement does not include the 2-foot edge or the 2-foot boundary line. Let's begin by labeling the dimensions of the basketball court using the inner edge and outer edge. So the court itself is 50 feet by 84 feet, which means this inner edge has a length of 50 feet. This inner edge has a length of 84 feet. And now this boundary line, or the boundary edge, is 2 feet wide, and therefore this distance and this distance are 2 feet at each corner. Let's label the lengths of the outer edges. This outer edge has a length of 50 feet plus 2 feet plus 2 feet, which equals 54 feet. This outer edge has a length of 84 feet plus 2 feet plus 2 feet, which equals 88 feet. And now let's look at the questions. If the boys had to stay outside the lines of the court, what was the least distance they would run? Give the answer in feet and miles. And B, how much more would someone run that stayed on the outside edge versus the inside edge? Give your final answer in feet and miles. Let's begin by defining the variables to keep things organized. Let's let P sub 1 equal the perimeter of the inner edge, P sub 2 equal the perimeter of the outer edge, and therefore we'll let R sub 1 equal the distance run using P sub 1, the inner edge, and R sub 2 equal the distance run using P sub 2, which is the outer edge. And then finally we'll let D equal the difference in distance run. Let's begin by determining the perimeter using the inner edge and outer edge. Using the inner edge, P sub 1 is equal to the sum of the lengths of the four sides of the inner rectangle, or using the perimeter formula, we'd have 2 times 50 feet plus 2 times 84 feet, which is equal to 100 plus 168, which equals 268 feet. And now we'll determine P sub 2, the perimeter around the outer edge. This would be equal to 2 times 54 feet plus 2 times 88 feet, which is equal to 108 plus 176, which equals 284 feet. And now let's determine R sub 1 and R sub 2, the total distance run, if the boys have to run 15 times around the entire court. So R sub 1 is equal to 15 times P sub 1, the perimeter around the inner edge, so 15 times 268 feet, which is equal to 4,020 feet. And R sub 2 is a distance run 15 times around the outer edge, which is 15 times 284 feet, which is equal to 4,260 feet. Let's continue on the next slide. Part A asks, if the boys had to stay outside the lines of the court, what was the least distance they would run? Give the answer in feet and miles. Well, we now know if the boys ran around the outside edge, they would run at least 4,260 feet. But we're asked to express this distance also in miles, so now let's convert 4,260 feet to miles. To do this, let's first write this distance as a fraction with the denominator of 1. So we'd have 4,260 feet over 1, and now we will multiply by a unit fraction, or a fraction equal to 1, to convert feet to miles. To do this, we'll use the conversion 1 mile equals 5,280 feet. Because we want feet to simplify out, we want a unit fraction where the units of feet are in the denominator, and we'll have miles in the numerator. And the conversion is 1 mile is equal to 5,280 feet. Notice this fraction is equal to 1, and in this form, the units of feet simplify out. So multiplying, we have 4,260 divided by 5,280, and now the units are miles. And now we simplify the fraction. 4,260 and 5,280 share a common factor of 60. So to simplify, we divide the numerator and denominator by 60, which gives us the simplified fraction of 71/88, and the units are now miles. So now we know if the boys stay outside the lines of the cord, they will run at least 4,260 feet, which equals 71/88 of a mile. Now for part B, we're asked how much more would someone run that stayed on the outside edge versus the inside edge? Give the answer in feet and miles. To answer this question, we first need to find the difference in distance running along the outside edge versus the inside edge. So we first determine the value of d. D is equal to the difference in the distance run, which should be 4,260 feet minus 4,020 feet, which is equal to 240 feet. So this is how much more someone would run running along the outside edge versus the inside edge. But we also need to express this distance in miles. So starting with 240 feet as a fraction, with the denominator of 1, we multiply it by a unit fraction to convert the units from feet to miles. We will use the same unit fraction we did above, which is 1 mile per 5,280 feet. Again, notice how the units of feet simplify out, leaving us with the fraction of 240 divided by 5,280, and now the units are miles. To simplify this fraction, 240 and 5,280 share a common factor of 240, and therefore we divide 240 by 240 and divide 5,280 by 240, which gives us a simplified fraction of 1 over 22 miles. So now we know if someone runs along the outer edge, he runs at least 240 feet or 1/22 of a mile longer. I hope you found this helpful.